Greetings to you all. Today we'll be building a common IC we see around using Proteus. Proteus is a software used for making simulations of electrical circuits. So an IC is a certain abbreviation of integrated circuit. So circuit is basically something that has a power, ground, some components, literally. But integrated circuits joins a lot of circuits to do one thing, and they are normally like made in small chips. So this is what we are going to be reproducing. Let me zoom in into it. This is the L293D motor driver IC, which has 4 inputs, input 1 to input 4, with 2 controls for the input, so enable 1, enable 2, enable 1 for input 1, input 2, enable 3 for input 3, input 4, and it has 4 outputs. So enable 1, enable 2 produce out 1, out 2. Input 3, sorry, not enable input, so input 3, input 4 would bring out output 3, output 4. The basic functionality is when input 1 is high, whatever is at VS will show here. When input 1 is also low, whatever is at ground will show at output 1. So input 1 is like directly connected to out 1, and input 2 has a direct connection to, not direct as in like the wire comes here, but whatever is here shows here. But it only shows there when VSS and enable 1 are also activated, so they are all a high. From the data sheet of this IC, we have a maximum of 36 volts. That means the motor you're going to drive should not exceed 36 volts. I've made some buttons here to supply the input to our IC. These are the enable pins. This is a power source of 12 volts, and this is a probe to tap that 12 volts to other places. This is ground, so 0 volt. This is a probe to tap that to other places. So now let's look at a simulation of how this works. So let me turn off the enable pins off. Let me turn them off. And when these controls for the bottom motor, we are seeing that forward is on, reverse is off. That means you're expecting this one to move in this direction. So when I press run, nothing is happening because VSS is 1 because it's receiving 12 volts, but enable, we are focusing on just motor 2, the bottom one. Enable 2 is not high. So if I come here and I turn it on, you see it's moving. So the enable and then the VSS are used to decide whether any inputs affect the output. And we can change the direction of this thing by just changing the flow of current through the circuit, and that's usually all what you do. So let me explain the concept behind the rotation. Okay, so I'm going to bring a circuit. So this is also going to explain to us what is happening. I'm just going to use for one motor. So you have these 4 switches here which are all open, and they are going to be used to control the direction of motor. And if you look at it carefully, it looks like an H, so it is called an H bridge. Depending on which switches are closed, the motor would move in a certain direction. So let's simulate this. And remember, we tapped the 12 volts from the DC source, so this is like 12 volts bringing here, and that's the ground we tapped here. So if you could see, there's a red symbol, that means there's power here. But since this switch is not closed, there's nothing coming here, and there's also power. Since it's not closed, there's nothing moving from here to here. There's blue, that means there's ground. There's nothing, it's not closed, so you can't move up. So let me close this one and close this. You will see the motor is spinning in this direction. That's like a clockwise or moving rightward, right? Let me turn this off, and let's do for this and that. You will see I've changed the direction of the motor. So that's telling us that if you're able to configure a certain setup such that when you press forward, it controls this switch and this switch, when we use reverse, it controls that and that. Then we are sure that we can be able to turn the direction of the motor. And the motor is not really polarized per se like a diode or something. So you just need to know the flow of current in a direction that will change the direction of the movement. Example, when you want to control a vehicle for your project, you want the vehicle to move forward and backward, you need to know how to get an IC or certain circuit that will help you do that rotation without getting a new set of controls. That's a lot of problem. So let me pause the simulation for now. So as you are thinking, yeah, we need all these 4 switches just to control one motor forward and backward. That means if you want 2 motors, we could replicate this. So you right click on the selection and you click block copy, and then we have 2 of them now. We can now run the 2 and then we could see they are all moving. We can change the direction of one just to show you that things are working a little bit. So let's enable 1, 2, and then they all move. Let me change the direction of one. Okay, so that's it. So now let's try and design this IC. So because as it stands here, we now know that we need some switches to do certain things, but we don't know how to bring in the logic of when the enable is off, let it go off, and then we have to bring another logic to also replace switches, because when I see it's a manual switch, I have to press it before it turns on. So we need to know how to control that. So in other words, I'm going to change the switches with a certain electrical component that can act like a switch, and when we supply it with a 0 or a 1, a 0 is logical ground, and then power is logical 1. Okay, so let's just pause the simulation, and I'm going to bring that circuitry out. Great. So as you can see, let me just focus on just one part of it. Okay, that's this part, and we are seeing the same H bridge over here, but now instead of switches, you are seeing a component here called a transistor. It's a bipolar transistor, and then the last part, which is the collector, and it has 3 parts. That's the base, that's the one with the resistor moving here, the emitter where the arrow is, and depending on how the arrow is pointing, there are 2 forms, that is NPN and PNP. So credits to my lab partner Steven Tego. He taught me a very simple way of identifying this, that is when the arrow is pointing inward, it is pointing in perfectly, therefore PNP. We need acronyms to remember things easily if that's something you really want to consider. Also for NPN means not pointing in, so we need to look at the arrow, see it's pointing out. So as the name is PNP, that means what you supply here must be positive and the output will be positive too. And then what you need to supply to the base is the N. That means you need a certain low logic at the end. Whenever you supply a low here, you cause a certain virtual circuit switch to close. In that case, whatever is here will pass through here and move here. But for the NPN, you need a certain ground somewhere here, and then whatever current is here will have a way to pass through and go to ground. So that means the base here must have a higher voltage, okay, a high voltage level. So looking at it, we've given both of them the same control. So let's say R1 is 0. When R1 is 0, this one will be activated. That means the power from here will pass through here and will be available at this point. But this guy will be open because he needs a 5, a 1, not a 0. So it's going to be something like this. So when you provide a 0, here will be closed, but here will be open. Now you come to this other end too. When you provide a 1 here will be closed, here will be open. So when we provide, here will be open and here will be closed. And this is going to be the configuration. So when there's a 0 here, this PMP closes, and then this MPN opens. When you provide a 1 here, this PMP opens still, and then this MPN closes. So that means you're going to have current flow like this. Also here, so it's going to flow like this, then like this, then like this, and then it goes down. And in that case, the motor will begin to spin in this direction. And then the other way around too. So when you provide a 0 to F1 and a 1 to R1, when it's a 1 here, here opens, here closes, here closes, here opens. It's going to be like this. So when here is 1, here opens, here closes, then here will close, then here will open. This is going to be a 1. So this is 0, 0 here, 1 here. This is the logic. 1 here, 0 here. We get it. They're going to get current flowing from positive passing here, then going out. So the motor will take this direction. And that's what they are seeing here. So you're going to see it current to move here, move here, move here, move here, move here, and go down. So the motor will turn this direction. Now, for the logic part, what you are seeing here is an AND gate. So we have two diodes that needs to be activated for current to pass through them. And when a diode is reversed biased, current cannot pass through it. In other words, it allows current to flow in just one direction. So from the positive to the negative aspect of it. So the positive is the long one, the negative is where the arrow, the arrow ends. So looking at this, they end because when here is when the voltage here and the voltage here are of similar voltage levels or are all high, then we pass. So 1 1 1. But when one of them is lesser than the other, current will try to pass through the path of least resistance. So it will come from the 12 volts, try to pass through enable 1 or through motor 1 reverse. In that case, this part will be seeing a ground. That means the current did not escape all of them. It got someone to pass through. Great. And this is what we use to verify the input such that the enable can be able to control the input I'm bringing. So you see, I'm bringing motor 1 forward. Forward is not sent directly to the motor. It's the output of the forward and with the enable. If enable is on and forward is on, then we have 1 1, then the output will be 1. Then you're going to tap that output to F1. When reverse is on and enable is on, then you're going to get 1 1 1, then R1 also be 1. If it is off, and if it's off and it's even off, you're going to get 0 0 0. So then it will be 0. So this the control part for the enable we're seeing here. So the names of the PMP I'm using is 2N3906 and the MPN is 2N3904. And when you're choosing the motor, just choose motor and choose animated, okay, if you want to follow along. So let's simulate what we have currently. So let's be observing the two motors. Let me try to bring this a little bit, organize this a little bit so you can see them well. So let me drag this one down. Let's move this team up. Great, so then you can now drag. So let's simulate and see. So as you can see, the top is motor 1, and you can see they are all moving in the same direction, and the bottom is motor 2, and they're moving in the same direction. So for both of them, when I click enable 1 off, both tops go off, but the bottom keep working. And when I turn off the down 2, both go off. When I enable this one, they go on. If you want to change the direction of them, just change the direction, and you can see they are all changing the same direction. So that's it. So thank you for watching, and I hope you learned something new, and see you another time.